Okay, let's go. My name is Andy Robbins. Thank you, Alan, for the kind introduction. I'm the co-creator of a tool called Bloodhound. This is the logo for it. I'm now the product architect for the commercial version of that software called Bloodhound Enterprise. I work at a company called SpecterOps, like Alan mentioned. And on Twitter, you can find me at _Waldo with a 0. Here is our agenda for the talk. First, why abuses and not bugs? Then we'll do a crash course through the basics. And to explain my own abuse research methodology, we'll look at a case study of some research that I did recently regarding the MS Graph API. I'll share some ideas about where you can find research opportunities for yourself, and then a conclusion at the end. So, why abuses and not bugs? In looking at the talks for this conference, there are a lot of very low level, very technical, let's find bugs in Android, or let's find bugs in ARM, or let's find bugs in some other kind of software. Our team and our company generally focuses more on abuses rather than bugs, and there are a few reasons why. First, generally, abuses compared to bugs enjoy a dramatically longer shelf life. PSExec has been around for 20 years, and adversaries still use it very reliably every hour of every day. MS-08067, not so much. Eternal Blue, not so much. Obviously, they're still there, but the abuse primitives are generally way more reliable than bugs. Over time, they are also much cheaper to maintain. Like I said, PSExec, thank you, Mark Rasinovich, for that. It's very stable. It works. You don't really have to patch it to be able to target a different Windows operating system version like you do with MS-08067, for example. So maintaining abuses over time is very easy and cheap. The abusable configurations or circumstances generally exist in every single instance of that platform that you're doing your research against. So who has seen someone have local admin in Active Directory when that user shouldn't have had it? Everyone. Who has seen MS-08067 in the past 12 months? Maybe some of us, yeah, maybe, depends on where you go. Finally, on the detection front, abuses present a notorious challenge for detection engineers. It is extraordinarily difficult to tell the difference between legitimate usage of an administrative protocol and illegitimate usage of an administrative protocol, especially when it's the same user to the same system. It's extremely difficult to see the difference as a detection engineer. If you don't believe me, believe the Gruck. He said, give a man an O day and he'll have access for a day. Teach a man to fish and he'll have access for life. If you don't believe the Gruck, believe Matt Graeber. He says, a sufficiently advanced threat actor is indistinguishable from a competent system administrator. So for these reasons, these are why we focus more on abuses and discovering what those abuse primitives are rather than bugs. If you want to find bugs and get a bug bounty, more power to you. I go with God. But, here we're talking about abuses. So let's go through a very quick crash course of the basics. Maybe just by a show of hands, who has worked with Azure before? Maybe half, yeah? Okay. And of those who have worked against the Microsoft Graph API, about half of that half. Okay, great. So for the rest of us, I'm going to explain some of the very, very basic concepts of Azure so that we're all speaking the same language. First of all, what exactly is Azure? Azure, depending on who you ask, can be different things. So my definition is I say that Azure is the all-encompassing suite of services that comprise Microsoft's cloud computing services and platform and product. So when I say Azure, I basically just mean Microsoft Cloud Computing, as it is distinct from AWS or GCP. Azure itself is actually comprised of more than 600 distinct services that cover all kinds of services: identity, compute, storage, data management, DevOps, IoT, you name it. If you can do it with a computer, you can probably do it with Azure. There is a very specific, okay, that stopped working. Oh, we're back. Oh, no, yes, no, yes. Okay, we're back. There's a, no. Yes. Yes, no, yes, yes, no. I can just project as well. Is that okay for the video? For the video recording, is that okay? All right, I'm just gonna project. So there is a very specific securable object hierarchy in Azure, regardless of what service you are using. If you're using M365, if you're using Azure AD, if you're using Azure RM, the same hierarchy will apply. So whatever you're doing, the very top level object is called a tenant. This is equivalent to an on-prem Active Directory domain head. And so the tenant controls what is known as a trust boundary. Anything under the tenant, anybody with control of that tenant has control of everything within that tenant. Directly under a tenant, you have different object types. You have app registration objects, service principals, devices, which can be Windows, Linux, whatever, security groups, and users. If you want to actually do any kind of compute with Azure, like you want to stand up a virtual machine, or you want to have a key vault or something like that, you have to start using Azure RM or Azure Resource Manager, which is also something that people just call Azure. Now, that hierarchy, you want to try this one? Okay, hello? All right, how's that? Can you hear me in the back? Good, okay, great. So if you are going to have compute resources managed under an Azure tenant, then that hierarchy starts with what is called a root management group. This is a management group, and under that management group, you can have one or more management groups. Under that management group, you can have one or more management groups, or none. Under a management group, and that can nest, I don't know, forever maybe, or maybe up to 255 nestings, I don't know. Under a management group, you have what is called a subscription. Under a subscription, you have what are called resource groups. And under resource groups, you have the actual resources. And so, for example, a virtual machine, a key vault, a database, or a blob. Authentication can be done using either a service principal or a user. A service principal is just as good as a user, maybe actually even better than a user. When you authenticate to a service in Azure, there is a token issuance step-by-step that happens. So our principal there on the left, that can be a user or a service principal, will authenticate via the security token service to the service that it wants to act against. And so, for example, this principal is authenticating against the Azure AD directory service. But as you're doing this authentication, you can also specify an audience for the resultant token that you get, which I'll show on the next slide. And that token that you get back will specify, in this example, that we want to access something via the MS Graph resource app. Whatever resource it is that you're accessing, the principal, because its identity is controlled by Azure AD, it will be authenticated by Azure AD, specifically by your tenant. When you get a token back, you get what's called a JWT, or some people refer to this as a JOT. And some relevant things that are in the JOT, which is base 64, but you can decode it very easily. The audience, there we have it, the graph, and roles, just as a quick example, it will list out what roles that principal has for that specific audience. And in this example, we have this app role assignment.readwrite.all, and I'll explain what that means later. So what about access control or authorization? This is where things get extremely complex in Azure. So different objects at different scopes are controlled in different ways. For example, the objects that are directly under a tenant can be controlled by Azure AD admin roles, MS Graph API permissions, the legacy Azure AD API permissions, object scoped admin roles, and the objects that are highlighted in blue can also have one or more or none explicit owners of their object. So there are already 5 different distinct access control mechanisms just for this scope of objects here. In Azure RM, you also have Azure admin roles, which are not Azure AD admin roles. Are you confused yet? I was. For blobs, there's also ABAC, attribute-based access control. And then certain objects like key vaults have their own permissions model specific to that object. How much fun is that? Like, if you're an admin and you're trying to determine who has control of any of these objects, you have to have a perfect understanding of all these different access control mechanisms. And of course, there is no one click in Azure to see the effective permissions against any of these objects. That would make way too much sense. Additionally, Azure has the concept of permissions inheritance. So if I describe a permission against my root management group, for example, that privilege will inherit down to every object under that root management group. Admins cannot change this behavior. Or if I set a permission at a subscription level, that also will inherit down to all of those descendant objects. The same is true at the tenant level. If I specify a permission at the tenant level, that will inherit down not only to all of the objects directly under the tenant, but also all objects that have a trust relationship through a subscription to the tenant. Okay. Let's go through a case study of what my methodology was for discovering the abuse primitives that are possible through the MS Graph API in particular. I heard about the MS Graph API from a coworker, Daniel Heinzen, also known as HotNops on Twitter. And basically he told me, hey, this looks like a pretty cool thing. Maybe there's something interesting in it. Why don't you take a look? Here's what I know about it so far. And that was about it. I didn't have any kind of administrative experience with MS Graph. So it's not as if I was an admin of it for 2 years and knew it very intimately. But that's okay. Like, you can do these abuse primitive researches against technologies that you don't have experience with. And this is how I do it. This is how I did it for MS Graph. At a high level, I'll start with what the entire methodology is, and then we'll dig into each step. First, I try to begin with the end in mind, then study the intent and the design of the system, explore the system using various means and from various perspectives, catalog the actual abuse capabilities that are exposed by the system, and then share findings. And so these steps comprise my own abuse primitive research process. And we will start by looking at the beginning, which is to begin with the end in mind. Essentially, in this step, there are several things that I want to lay out to basically establish success criteria for myself. That, did I succeed in this abuse primitive research process or not? And so I start by, laying out what I want to understand. I want to understand the fundamental mechanics of the system, how it works behind the scenes. I want to understand how it interacts with other existing systems that I already know about, or discover new systems that it interacts with to have as future research. And obviously, I want to know how the system can be abused. I want to produce a blog or a talk for others to be able to understand what I have learned so that others can build on top of that. For defenders, I want to be able to produce example audit code so that they can audit for these dangerous configurations themselves. And I also want to produce example abuse code so that people can prove that these configurations actually are abusable easily. I also want to produce practical remediation guidance, especially for defenders, so that if they find something in their audit, they know what to do about it. And it's something that is practical and doesn't require like a P5 license to do, or just, giving Microsoft more money. And because I'm a product architect for Bloodhound Enterprise and also for the free version of Bloodhound, for me, I want to know what is the impact on my existing graph model going to be, because I don't want the performance of my graph to degrade because I extended the design of the graph in a way that I didn't anticipate that kind of degradation for. I want to know how to expand the graph model. And I want to know what data do I need to collect? How do I collect it? Where are those objects? And then how do I ingest that into the Bloodhound database? So the end result of that very basic first step, which is basic but critical, is that I've established success criteria for this research. This is more important than it might sound, because if you dive into abuse primitive research without this kind of end goal in mind, that's, for me at least, a way to rabbit hole into several different things, get distracted, lose focus, and basically produce nothing of value. The next step for me is to study the intent, the design, and the usage of the system. I don't have first-person administrative experience with this system, but I can glean that experience from others who are involved in the architecture and design of the system, and also the people who administer the system as well. There are a few different resources for doing this. I always start with the official documentation, both technical and non-technical. What does that mean? It means a lot of this. And so after my conversation with my colleague, literally my first Google search would have been Microsoft MS Graph. What is that? I don't know. So you Google that, you'll find the Microsoft documentation for Microsoft Graph. And this documentation is not written for somebody who's trying to figure out how to abuse the system, obviously. It is written for somebody who's more of an admin, or maybe somebody who's a decision maker and they're trying to decide between AWS and Azure. It depends. The documentation at Microsoft is all over the place. So one of the interesting things on their documentation is, what can you do with Microsoft Graph? And going through this, eventually you'll find that there's a use case they describe for a help desk person being able to reset somebody else's password. Okay, that's kind of interesting from an abuse perspective. So let me Google that, MS Graph reset user password, and I'll find this. So there is a method in the Microsoft Graph REST API called password authentication method reset password. What's more interesting on this page is if you scroll down, it starts to describe the permissions that are required in order to do this. So if Microsoft Graph is going to allow you or not to reset someone's password, it does this assessment of the privileges that you hold. So now I can start to understand that there is a distinct permissions model, distinct from the Azure AD admin roles, that I need to understand. And so back to Google, MS Graph permissions. And you have a nice permissions reference page on the official Microsoft site. What this documentation covers is basically the names of the permissions and then a very basic human readable explanation of what that permission is. But they don't tell you how the permission model works behind the scenes. So we'll talk about that later. So maybe my initial notes at this point might be something like this. MS Graph is some kind of Azure-related service. It exposes a REST API. It can let you reset someone else's password if you have the correct permissions. And it seems like it has a distinct permission system from Azure AD and Azure RM. Okay, so some decent initial notes. Next, though, I need to get that kind of secondhand perspective from people who have been working with the system for a long time and try to make their experience my own as best I can. So through those people, I will find code repositories, blogs, and talks that other people have done on this topic. One of the most reliable methods for me is to look at the people at Microsoft who are responsible for this system. So if I look for an architect for Microsoft Graph on LinkedIn, there's actually maybe more results than you would expect. And you can start to look through these people's profiles. You can find their Twitter profiles. This is very similar to just doing like basic open source intelligence gathering, but instead of finding a person to attack, you're trying to find a person to learn from. Helpful person here is Daryl Miller. So he's actually the API architect for Microsoft Graph. And just scrolling through his Twitter feed, very, very quickly, you can find good resources that he has retweeted or that he has written himself. And so this is a great example of a PowerShell deep dive into the Graph API. I personally love using PowerShell. So for me, this was very relevant to try to understand, how do I interface with the system? How do I communicate with the system? And then additionally, there's like great write-ups you can find like this, 30 Days of Microsoft Graph blog series that goes into all kinds of very technical things. And then I'll also look at talks and spend maybe 12 to 24 hours just watching talks. Talks are very good. Usually people are a little bit looser than they are in writing, and they usually give up some more detail than they typically would otherwise. So you can find really good nuggets watching people's talks on this topic. Finally, I'll look for community resources. This is extremely helpful because while the Microsoft people are a little more cagey about some of the bad details about any of their products, the community is very, very open and very loud about those issues. And finding those issues means that you can find bugs and you can find abuses. So a really good example is on the PowerShell SDK GitHub repo. There are hundreds and hundreds and hundreds of issues, both open and closed, where you can find all kinds of conversations. And this is where you can just easily find something like, well, this interface doesn't support MFA. Okay, that's very interesting. Or this permission, which says it needs a human to approve, actually it doesn't. So that's also very interesting for a red teamer or somebody trying to abuse this system. After going through all this, my abuse notes or my initial notes look like this, and then my updated notes might look something like this. Microsoft is investing into MS Graph as a sort of API for APIs, a unifying endpoint that may eventually allow for indirectly interacting with any object in any service just by interfacing with MS Graph. So that kind of consolidation strategy from Microsoft, to me, means that it is worth investing time into learning this system. MS Graph's REST API is instantiated into every Azure tenant as a resource app, aka enterprise app, aka service principal, aka first-party app. There's a lot of very confusing language. A lot of these different phrases mean the exact same thing. But this fact that the MS Graph is available in every tenant means that it is ubiquitous. So no matter what organization I'm trying to target, if they use Azure, they use MS Graph. And so that ubiquity means that I can apply the same tradecraft that I learned here to anywhere. MS Graph brokers requests of particular Azure services, including privileged action requests like resetting passwords or adding users to security groups. Okay, great. So at the end of that phase, the basic success criteria for that phase is to have built some foundational academic knowledge. I haven't done anything practical at this point. I'm just basically reading and listening and looking at talks and just taking everything in that I can to have this very academic high-level knowledge. Which, of course, brings us to the next step, which is to start actually interacting with the system and start exploring it in various ways. I think it's actually very important to have built an academic knowledge base before going into the technical details of a system, because without that context of the intent and the design and the usage of the system, you're basically just spelunking into a cave of a technical system that you don't really know why it exists. And so for me, that's a way to just waste a lot of time. To that end, you must go beyond the documentation, in particular with, let's say, cloud products. These systems, they are interconnected and they behave in undocumented and non-public ways. The documentation, if you have ever read the Microsoft documentation, you know this is true, that often it doesn't keep up with changes to the system and it quickly goes out of date. If you make tooling based only on documentation, I can almost guarantee you that it will be inaccurate and unreliable. So what do we do in this phase? For me, the easiest way to start exploring a system is to use the easiest administrative interface for that system. For the MS Graph API, that means using the Azure Portal GUI. So I'm not going to go into too much detail about how that works in the GUI, but one thing that is extremely useful when you are using the Azure Portal, and if you're going to get into Azure research, this is something that you'll want to know. This is the Chrome browser that I'm looking at the Azure Portal GUI with. And if you bring up the developer tools, you can see all of the different requests that the browser is making to that API. The Azure Portal GUI is actually primarily API driven. There are some services that use like the JavaScript modules that are loaded to interface with services. But for the most part, the things that you click in the GUI, they are doing an API request through the browser. So you can see here, what did I click? I clicked on getting my user object here. And so in the developer tools, you can see that there is a GET request to graph.microsoft.com/v10/users/my-user-ID. What is very useful here is not only can you see the URI that is handling the request, and you can see the response in JSON format, but you can very easily get free API interaction code from the browser by right-clicking on the request, go to copy as PowerShell, paste that into something, and you have a pretty decent minimal client for interfacing with the MS Graph API. You do have to make a change to this. You have to get rid of that refer line at the bottom, or else it won't do the request. Otherwise, you've got everything you need to start a very, very basic client. We can copy and paste that into PowerShell, and the request there is at the bottom, status code 200, okay. And then we have the raw object that represents the user, and you can see that it's JSON formatted. Obviously, this is good for us because programmatically, it's very easy to manipulate and work with JSON objects. What I also like to do is look at the MS-authored CLI tools. So for Azure in particular, this can mean the AZ binary, the Azure AD PowerShell module, and the AZ PowerShell module. When you import these modules in PowerShell, are there any PowerShell users here? Not as many as I thought. Okay, so yeah, I love PowerShell. I can't say enough good things about it. Obviously, because Azure is API driven, you can use whatever you want. So you could use curl if you would like, or just use bash in general. But I love PowerShell. I'm a PowerShell fanboy. When you import a PowerShell module like this, like import module Azure AD, you can do a very simple command to see what are all the available commandlets in PowerShell for that particular module. So in this example, if I import that module and then get the commands that are exposed by that module, I've got all these different commandlets, and this goes on and on and on and on and on. And I say this because just reading the commandlet names, you can get an idea of what is possible beyond the documentation. And then the PowerShell commandlets, PowerShell is self-documenting. So if you look at the equivalent of a man page for a PowerShell commandlet, it will often include examples, although some of the Microsoft author ones don't include examples. But it'll show you how to use a commandlet, what the expected output is, and things like that. The existing Microsoft authored PowerShell modules are what I initially used to create something called Azure Hound, which is a data collection capability that feeds the Azure data into a Bloodhound database. And then finally, with exploring this system from different perspectives, we can create our own very basic client. So we did that already with Chrome, where we can copy as PowerShell, paste. But it's better to have control of your own very basic client, and for PowerShell in particular, to be able to create modules for whatever you want to do. Here's an example of the most basic MS Graph API client that I can conceive of. So at the top, we are accessing the STS service, the security token service, to get a token for MS Graph for this client, which is a service principal in Azure. And we're assigning the variable that we get back to the $token variable. The yellow highlight there, that is where we are accessing the API. Very easy. So with PowerShell, you have a method or a commandlet called invoke REST method, which will put the output of that optionally into a variable that you describe. So I'm putting the output of that into $users. And then you can work with the data that comes back. So users.value will show the raw information that came back, and it looks something like that. So these are JSON objects, but PowerShell will convert them to a PS custom object or serialize it as a PowerShell object. But you can translate back and forth between PowerShell object and JSON very easily. When you start doing this, you will start to run into issues, obviously. So one issue is that this user's endpoint and many of the Azure AD scoped endpoints, they will only return the first 100 objects that come back. So you have to go through a loop to page through the results. And so that looks like this. There are some gotchas with JWTs. So JWTs, they facilitate stateless authentication so that Azure doesn't have to keep track of your state like it does with a cookie. And it partly facilitates stateless authorization. But not all of that authorization information is stored in the JWT. The Azure AD roles and the MS Graph roles are stored in the JWTs. But if you have Azure RM role assignments, or if you have explicit object ownership, or if you have key vault permissions or whatever, that information is not stored in the JWT. So the TLDR is that you probably actually have more permissions than what the JWT describes. What are we doing here? So in this example, what I want to show you is that we are assigning our JWT to the $token variable. And then on line 20 right there, we are printing out the actual base64 encoded access token. We run that in PowerShell. It looks like this. There's a handy service you can use called jwt.ms that will parse your JWT. And there are some interesting things in the token to look at. One is the audience. So the audience is the service that the JWT is valid for, and it is invalid for any other service in Azure. The issuer, so this is the security token service, and then the ID that you see at the end of that is my own Azure AD tenant ID. The MS Graph scoped app roles are in the roles parameter, and then the Azure AD roles are in a parameter called WIDS. I think I have about 10 minutes left. Is that right? 15? Okay, cool. All right, we're doing well. So the final result of this phase of exploring that system from various perspectives is that we've created a very simple, very functional client. And so we've dipped our toes by studying how the official Microsoft authored tooling interfaces with the system. We went a little lower level by creating our own client so we can access the system in a more raw nature. We also now have the foundation for building a more mature client that we can use to do our abuse primitive discovery. And with all this context and with this very basic client, we also have the foundation for automating that abuse discovery process, which is what we will talk about now. So this next phase, it will catalog the abuse capabilities that are enabled by the system. First step, what are the permissions that are available by the system? We want to enumerate all of those. With our very basic client, we can do that like this. So MS Graph instantiates itself as a resource app, also known as a service principal. So we access it via the service principal's endpoint. And then we're just enumerating all of them and we're putting them into a variable called service principals. Then we find the service principal that matches the MS Graph resource app GUID, which is going to be the same in every tenant. And there is a property called app roles. And what this describes is all of the different permissions that are exposed by the app. Because they are exposed by the app, they are also scoped to the app. What that means is that an MS Graph app role cannot be used against another app. Does that make sense? So our graph app roles are only valid against the graph. They're not valid against Azure AD. They're not valid against Azure RM. They're not valid against anything else except for the MS Graph API. Or at least that's what the intent is. Maybe somebody can find a way around that. If you can, that would be worth probably several tens of thousands of dollars. So here's what I do. Here's what I did. I copied all of these different app roles. I pasted them into a spreadsheet. And then we're ready for the next step. Our next step is we're going to test the existing abuses that we already know about and consider new abuses that maybe we learned about through looking at the documentation or looking at the description for an app role or looking at a talk, whatever. Just keep an open mind about what the other abuse possibilities could be. So as an example, in the Microsoft documentation, there is this privilege called directory.readwrite.all. This says it allows the app to read and write data in your organization's directory, such as users and groups, without a signed-in user, does not allow user or group deletion. That's it. That's all you get. You don't get to know what the scope of actions are that are allowed by this permission. You don't get to know the scope of objects that can be touched by this. You don't know, does this affect Azure AD and Azure RM? Literally, this is all that we know, and this is why I say, if you make tooling based on documentation, it will be inaccurate, it will be wrong, and the people who use your tooling, including yourself, will be extraordinarily frustrated. So you have to go beyond the documentation when you're doing these tests. So, in this spreadsheet, I will start to list out the different abuse primitives that I already know about against Azure. So for example, can I promote myself to global admin? That's fun. Can I change a global admin's password? It's useful. Can I add a principal to a role-enabled security group? Okay, that's pretty good. And initially, when I started doing this research, I would do this. I would have an example application. I would give it one permission at a time. And then I would do abuse tests with that permission. So for example, let's give it accessreview.read.all. Is that abusable? Is it not? I don't know. We can't prove that from the information available from Microsoft. Here's an example of how to promote a user to global admin using the post method against this particular endpoint in the MS Graph API. So manually by hand, I will use that service principal's secret and authentication to try to promote itself to global admin. And I will get a 403, and I'll go back to my table, and I'll enter no. So there's about 175 MS Graph app roles, and the abuse tests that I was covering is maybe about a dozen. So you can do the math. It's impossible to do this by hand. You have to automate this process, which is what we will do. After you automate this process, you go from, I'm sorry, wrong slide. You go from something like this to the end result of what I have in my actual spreadsheet, which is this. So the actual app roles that can be abused, I have listed here, and then all the other ones that cannot be abused are just below that with all red no's. And so the example that we looked at before was directory.readwrite.all, which you could see in the middle of that far left column. And so it turns out that the two abuses that are actually enabled by that are we can add someone to a non-role eligible group, or we can add an owner to a non-role eligible group. So as far as read and write on all directory objects, I'm not so sure. The end result of this automation is, for me, I need to know how am I going to expand the Bloodhound graph database design. And so that would look like this. So this is what you were looking at before in the spreadsheet, but it is modeled as a graph. So we'll just look at the very top example. We have an AZ app that will authenticate as a AZ service principal. That service principal is granted the MS Graph app role called application.readwrite.all. And that gives them 4 different abuse possibilities. They can add a secret or an owner to an AZ app, or add a secret or an owner to an AZ service principal. So at this point, I'm ready to introduce these attack primitives into the Bloodhound graph. I haven't done that yet. It's coming soon. What you can also do is from this, you can create an example attack path. And then you can look for those examples and those patterns in real environments. And so after doing this research, we do red team assessments for organizations that use Azure. And one of the most common attack paths that we find for turning low privilege access in Azure into global admin relies on abusing these MS Graph API permissions. And such an example attack path looks like this. On the left, we have a user called Matt Nelson who has no Azure AD admin roles, doesn't belong to any role eligible security groups. If you were to audit this user using the Azure portal, you would see that this user has no permissions. What you wouldn't see is that this user has been added as an explicit owner on an app registration object. That app registration authenticates to Azure using a service principal. That's a one-to-one mapping. That service principal has been granted an app role called approleassignment.readwrite.all, which allows the service principal to grant itself or anybody else any MS Graph API permission. So they can give themselves role management.readwrite.directory, which means that they can then promote themselves to global admin. This is the most common privilege escalation pattern that we have seen in real Azure tenants so far. For defenders, it is very, very hard to audit any one piece of this. So that sucks. Another end result of going through this automation process is that you will discover where the official documentation materially differs from reality. So a good example is this. On the official documentation, it says that only an administrator can consent to application permissions. But if we rewind about 20 minutes, remember the GitHub issues that I was showing you before? One of those is, how do I automate granting consent for application permissions? And it turns out you don't need an administrator to consent if the service principal has a particular app role assigned to it. And so it used to be true, what's underlined in red here used to be true, it no longer is true. So you can find where the documentation is wrong. I was going to try to have this ready before this talk, but I didn't have it ready. But something that is coming soon is the automation framework that I've built. And so working title, Atomic Azure Tests. This is inspired by Red Canary's project called Atomic Red Team. It has no dependence on the PowerShell modules. It just accesses the Graph API using the PowerShell methods. You could easily port this to something else like Golang or Bash or whatever. It's an API. You can use anything to interface with it. And additionally, my intent is that it will be easily expandable to cover other Azure services so that you can take this and you can extend it to cover maybe something else that you're interested in. The end result for us is that we have daily automatic permission to abuse mapping available for anyone to see. So that will be coming soon as well. That's the end of that phase. So we've automated collection, audit, and abuse capabilities. Finally, we want to share our findings. I don't have a whole lot to say about this. This basically means write a blog, share your code, give a talk, let other people learn from what you have learned, and let other people build on top of what you have built or improve what you have built. Just help people save time by getting through this rigmarole initially. The way that I like to say that is write the blog post that you needed at the start. Let's go back to where we started. We wanted to begin with the end in mind. Here are all the things that I wanted to do. So I can check myself and I can see that, yes, I did all these things. So I feel good about that. I can move on to something else. Where do we find research ideas? Like I said at the beginning, Azure lets you basically do anything that you can think of with a computer. So if you have existing expertise in databases, maybe look at the Azure SQL database service, or DevOps and CI/CD, or web apps, or infrastructure management. There's a full maybe list of what those services are at that link. In reality, there are probably more services than what are documented. I also recommend following people in leadership at Microsoft because they often talk about new cool things that are coming out, and those new cool things are ripe for abuse research. Follow these particular people who don't work at Microsoft. They are always putting out high quality, high signal content specific to Azure. There's a link to this deck at the first slide, which I'll bring back up so you don't have to rely on taking a picture of this. Bookmark these pages and read these every so often. Which brings us to our conclusion. There has never been a better time than right now to get involved in abuse research specifically against Azure. Azure has been around for more than 10 years, but really it hasn't been adopted by the mainstream until the past 2 or 3 years. There's a lot of misconfiguration debt in the system. There's a lot of opportunity to discover new abuse primitives. I hope that in this talk, I've shown you how easy, if tedious, it actually is, and I wish you happy hunting. And with that, I'll thank you, and you can find me on Twitter right there.
Thanks a lot, Andy. It was an awesome talk. Since we started a little bit late, we'll give it five minutes or so for questions. So if anybody has a question, please raise your hand.
Thank you for the great talk. I always find these talks very inspirational. But from my experience, the hard thing about these research projects is managing your time. So how do you go about managing the time? And also, these goals for the stages, for the phases that you set are kind of abstract. There is really no way to find if you have researched the documentation enough. And it's really hard to sell to yourself, like spending additional time here and there. This is the first one. And the second one is very, very short. Are the Azure APIs stable so that your tooling does not get outdated?
Those are great questions. So the first question was, how do I manage my time? It's difficult. I'm fortunate to have working hours available to me during the day from 9 to 5 that I can do this research. Not everybody has that luxury. So when I did not have that luxury, it was sitting at a bar like on the weekday evenings. It's challenging, but I also have maybe a more personal answer, which I'll answer personally to you. Your second question was, the stability of the tooling. Yeah, that is a great question. So you might notice that in some of those requests that I was doing, I was specifying a version of the API to hit. The last stable version for the MS Graph API came out in 2015. There are beta versions available as well that you can hit, but certainly my belief is that if you specify the API version, that the service should behave the same way. Maybe, maybe not. Probably not. And did you have another question in there too? No. Okay. Good questions.
Any other questions?
Oh, over here.
Yeah.
Thank you. First, thank you for Blue Down. It's helpful every day. So
cool.
Thanks. Then, how long did something like this take from the start? So your friend tell you, "Hey, look at that. It's interesting," to the end of your.
Yeah. So the question is, how long did it take to go through this process from hearing about it initially to having a product or a talk or whatever? It took about 2 months. Now, it could have been a lot faster if I would have figured out the automation process earlier. The truth is that the resulting table that you saw earlier, I actually did do that manually by hand. So that took a long time, but that's what took most of the time. But with the automation framework, I think that could be compressed down to maybe a couple of weeks, maybe 2 or 3 weeks. That's my intent. With Bloodhound especially, I want to extend the scope to cover other abusable services. And so part of my responsibility is to have that abuse research and practical application process more mature. And so this is what I'm doing now with other research that I'm doing now, is automating that as quickly as I can. So now I would say it's 2 or 3 weeks to go from hearing about something to have something that is publicly digestible, I would say.
Okay, so we have time for one more question and then we'll move on.
Thanks for the talk, really interesting. One of my question is actually, what do you do when you find an abuse? Especially like in the documentation, you show us that it was actually wrong.
Yeah.
Did you inform Microsoft, and what was the reaction that they had?
Yeah. So I did have a few conversations with people at Microsoft around this. I also submitted some PRs to the documentation repos to correct them. Most of them were rejected. But I did talk to the people at Microsoft about like the abuse possibilities with this system. And because this is the way that the system is designed, their response was, this is not a vulnerability, this is how the system works, which of course makes me happy because that means that my abuse primitives last forever. So they're not going to change this, and that means that Bloodhound will be correct when it shows you an attack path. And that means that the documentation that I write or the code that I write will stay the same. It doesn't need to change. And I agree with their position that it is the way that the system is designed and intended to be used. It's the same thing with abusing the service control manager in Windows to create or edit an existing service. It's the way the system works. Can it be abused? Yes. Is there something Microsoft can do about it? Not really, I don't think. It's like RDP. What are they going to do? So, yeah. And otherwise, there's other like documentation corrections that I've asked for them to make, or I've made the PRs, and I've asked. That's the best I can say is I've asked. Yeah. One more thing I'll say is I have Bloodhound stickers with me, but Charlie's talk is coming up. I don't want to interfere with Charlie's talk, so maybe find me in the lobby after Charlie's talk, and I'm going to stay here and watch Charlie's talk.
All right, thanks. Another round of applause for Andy.